In this section, we're going to start taking a look at measures of spread and how we calculate outliers, which we've looked at visually with graphs already. To start off, we want to take a look at standard deviation, which is a measure that we mentioned in our calculation for skewness without really establishing what that is yet, and IQR. Before we dive into either of those, though, we want to talk about the simplest measure of spread, which is the range of a data set. The range of a data set is literally the maximum value minus the minimum value. That just tells us how much distance there is between the largest and the smallest value. So if we were looking at, for instance, salaries, that would tell us the difference between the lowest earner and the highest earner. But what we want to look at, or what we use more commonly in statistics, are some better measures of spread that tell us more about how the data values are spread out around the center of the data set, rather than just the distance between the smallest and largest. The first of those is the standard deviation. And what we're going to do is build the formula for how we calculate standard deviation a piece at a time. We won't use that. We'll be using technology to calculate standard deviation for us because it's kind of an ugly formula, but to see where this idea comes from. So to start off, we have x minus x bar, which means we're going to take every value in our data set, that's what the x represents, and subtract the mean of the data set. That is, we're figuring out how far each individual data value is from the mean, or how far each individual value deviates from the mean. Then what we want to do is take the average of all of those deviations. So we're going to divide by n, which is the number of data values that we have in the data set. So what we're doing is essentially averaging the deviation from the mean. So on average, how far are our data values away from the mean? But now we're going to mix in a couple of other things to our formula. We're going to add this summation symbol. You maybe haven't seen that before, but that's just telling us that we're going to repeat this subtraction calculation in the numerator for all of our data values. We're also going to square that difference so that all of those differences are positive, rather than looking at some of them being positive, some being negative. And to essentially undo the fact that we're squaring that, we're going to square root this whole thing. And then if what we're calculating is the sample standard deviation, we're going to subtract 1 from that sample size in the denominator. So that's our formula for sample standard deviation. If we were calculating population standard deviation, meaning we are calculating that from data from the entire population, we would divide by, it's usually written as capital N, but the entire sample size rather than the sample size minus 1. So again, the things to really pay attention to with this formula is that we're finding the difference between each data value and the mean. So how much deviation there is between each individual data value and the mean. And then we're averaging all of those distances. So the standard deviation is the average amount of deviation, the average amount of difference between our data values and the mean. The IQR, which is short for interquartile range, is calculated as Q3, the third quartile of our data set, minus Q1, the first quartile. And if we sketch out a quick box plot here to refresh ourselves on where these data values fall on our box plot, Q1 is the left end of that rectangular region, and Q3 is the right end of our rectangular region. So when we calculate Q1 minus Q3, the IQR, what we're calculating is the distance between Q1 and Q3, the width of that rectangular region, and that represents 50% of our data values. But again, what both of these measures are doing in different ways is just calculating the amount of spread. The standard deviation is looking at how far on average values deviate from the mean, and the IQR is looking at the spread around Q2, which is the median.